everybody. So in today's video, I'm going to be using C++ to plot the implied volatility surface using the Stochastic Alpha Beta Rho model. So let me go ahead and exit my camera because it's going to be very memory intensive. Okay, so I'm here in my C++ file. What I want to do first is define the ticker. So that would be string ticker equals, I'm going to just do it for Microsoft. So now I need to pick the row parameter, which is the correlation, and that is going to be double row equals negative 0.5. So now let me go ahead and fetch the data. So I have boost property tree imported here. So what I'm gonna do is I'm gonna come here and I'm gonna do vector double pull stock data, and the input is just going to be the ticker. So it'll be std string response equals request FMP address of ticker, and then it'll be std string stream ss of response ptree data set, and then read json ss data set, and then it'll be for ptree const iterator it equals data set dot begin. It is not equal to dataset.end plus plus it. So it's going to be if it first equals historical, it'll be for ptree const iterator of jt equals it second dot begin. Jt is not equal to it second dot end plus plus jt. So then in here, let me actually go ahead and declare my vector. So I'm going to do std vector double close, and then it's going to be close.pushback atof of jt second dot get value std string dot c underscore str. Oh, wait a minute, hold on. Let me go ahead and exit that. So if jt first equals adjusted close, then do this and close that off, and then we want to reverse it because the newest price comes first and the oldest price comes last, and we don't want that. So that'll just be std reverse of close.begin close.end, and then return close. Okay, so to make sure this works, what I'm going to do is create a function called extract close, or rather, no, this is just going to be double stock price, and it just takes the vector close and it returns close of close.size minus 1. So now what I'm going to do is come over here and do vector double close equals pull stock data of ticker, and then double stock price equals stock price of close. So now let me go ahead and run it. S end line. So I don't let's see. What was I gonna do? Okay, so I'm gonna print stock. So I'm gonna do ./SABR.sh Okay, good, no errors. A dot out. Segment fault, core dumped. Okay, what is the issue? We go back to pull stock data. IC second, adjusted close. Maybe if I, instead of doing this, maybe it'll be JT second dot get value double. Alright, let me run this now. Okay, so now dot slash a dot out. Segment fault, core dumped. Okay, let me see if this is the issue. Okay, so the request response, string stream. Yeah, let me go ahead and print response. So okay, let's see if like it's a data issue. Okay, no, it's not. Okay. Yeah, it was it did not error out. Okay. JT plus plus JT. Um oh, actually I was supposed to add another one, so I'll go ahead and come back here, do double S equals stock price of close, because now I know my error, so I'll do C out S end line. So now I will come up here and do for P tree const iterator KT equals JT second dot begin. KT is not equal to JT second dot end plus plus KT. So instead of JT, it'll be KT dot first KT. So now let me go ahead and compile it again and then run it. Reset. A dot out. Perfect. So we got everything we needed. So yeah, let me get rid of this now. So we have the stock data, stock price right here. So now to the model, we're gonna need some of the parameters. So what I'm gonna do is come over here. So I think what I'll do is like return them all through a map. Let me see if I have map. Yep, I got map here. So that's gonna be std map of std string. So from the historical set, I'm gonna pull the volatility. I'm gonna pull the volatility of the volatility. I already have correlation. Time to mature. Okay, yeah, that's gonna be in a little bit. Just trying to see. So yeah, volatility and volatility. Okay. Parameters. So it's going to take the vector of close. So it's going to be map string double result, return result. So in order to get the volatility, what I need to do is compute the rate of returns. So that'll be, let's see, double, no, std vector double of ROR. So for int I equals 1, I is less than close dot size plus plus I. So it'll be ROR.pushback of close of I divided by close of I minus 1 minus 1.0. So now we got the returns. So now we need two measures. We need the volatility and the volatility of the volatility. So I'm going to first compute the volatility. So it'll be, well, actually, let me just make the function. So that'll be auto vol equals std vector double, call it x. Also, I think I need to compute the mean. Yeah, because this is the standard deviation formula. So I'll just do stdev. And then up here, I will do auto mu. Now mean equals std vector double x. And then close this off and double average equals 0 for auto and I in x, which is going to be average plus equals I, and then return average divided by cast double of x dot size. So we got the mean. So now I'm going to come here and do double mu equals mean of x, and then double volatility equals 0. So this is going to be for int I equals 0. I is less than x dot size plus plus I. So then it'll be volatility plus equals the power of x of I minus mu squared, and then return the power of volatility divided by cast double of x dot size minus 1, 0.5, so we get the square root. Okay, so the first thing I'm going to do is I'm going to call this IVOL, and I'm going to do standard deviation of ROR, and now I'm going to come here and do double window equals 100. So, wait, how far does this go back up? Okay, I don't know. 423.35. Yep, it has the correct stock price. So Windows 100. So this will be double. Oh no, I'll create a vector. Double store vol. And then it's going to be for int I equals window. I is less than ROR.size plus plus I. So this is going to be std vector double hold equals ROR of, no, ROR.begin plus I minus window, and then it'll be ROR.begin plus I. And then I will do store vol dot pushback standard deviation of hold, and then I will do double vvol equals standard deviation of store vol. So yeah, the volatility of the volatility. So we have result. So result of IV is going to equal IVOL, and result of SV is going to equal VVOL. Okay, so now I could come over here and do map string double of vol equals parameters of close. So now that I got that, let me go ahead and print these out. So that'll be vol of IV tab vol of SV and line. So ./SABR.sh undeclared variable I, line 103. Oh, wow. Alright, let's see if that, like, generates any other errors. Okay, good, no errors, so I'm going to do reset, and I'm going to do ./a.out. Okay, so I have the volatility and the volatility of the volatility. So now that clears those two parameters. So the next thing I should do is uh, build a matrix around the strike price and the forward price. So in order to do that, okay, so so we got this beta. Oh yeah, let me just define beta equal to 1.0 just to keep this efficient. So we got beta, if we have rho. So yeah, just computing time. So let me come over here and do, I'm just going to do std vector double time equals, so I'll do like 7 days. I'll do, um, 14 days, um, 30 days, uh, 60 days, 90 days, and 1.0. Okay, so yeah, these will be our maturities. So now what I'm gonna do is compute the forward prices. So vector double FR for forward, and okay, this is what I'm gonna have to do. I'm gonna do for int t equals 0. T is less than big T dot size plus plus T. So it'll be FR dot pushback. Oh wait, let me also define a random interest rate. So it'll be double R equals 0.044. So then it'll be pushback of um, the stock price times e to the power of R times T of T. So we have our forward prices now. So what I should do is build the strike prices. So that'll be, so how many do I have in here? Because I want to keep this as a square matrix. 1, 2, 3, 4, 5, 6. 6 strike prices. So what did we say that stock price was? Microsoft. So I'll make 3 prices lower than 423, 3 prices above. So it'll be like, we just write here 423. So 1, 2, 3, 4, 5, 6. Okay, so this one has 1, 2, 3, 4, 5, 6, 7, 8. 423 is the stock price. Okay, so std vector double k equals, so I'll do 420, I'll just do 420. Now 8 of these, 4, 425, 430, 435. So this will be 415. Or actually, let me add bigger increments to this. So this will be 410, 420, 430, 440, and 450. Okay, so then this falls as the middle. So it'll be 400, 390, 36. I'll do it to 460. So there's 3, 6, 8. Okay, perfect. So these will be in a grid. So let me get rid of this. So now I want to build the forward, well actually let me go ahead and print out the forward price before I get too far ahead. It'll be for auto F in FR, C out F, end line. Okay, no errors. Okay, so this will work. So yeah, now let me create the grid. So I'm gonna go ahead and minimize some of these functions, like the ones that we've already done, like pull stock data, stock price, parameters. I'm gonna come here and define this as a map, and it's gonna be a string key, but a 2D vector. So that clears the vector. So I will call this grid, and it just takes the vector x and vector y. Okay, so now let me go ahead and copy this map. So it's going to be result, return result. So let me think of the best way to put these in. So what I'll do is for int I equals 0, I is less than x dot size plus plus I, create a vector double temp x, vector double temp y, and then for int j equals 0, j is less than y dot size plus plus j. So it'll be temp x dot pushback of x of I and temp y dot pushback y of j. So then I'll come down here and do result of x, or rather, maybe I should strikes. Yeah, strikes is going to be the x-axis, is going to be dot pushback temp of x, and result of expiry dot pushback temp y. Forward. Yeah, forward. And then return that result. So yeah, these are in a grid now. Well actually, I'm trying to think. Maybe I should do the actual vol surface in this. Yeah, why not? I mean, we're already here. Okay, so um instead of calling this grid, I'm just going to call it SABR. So now that we have this, okay, I think I will implement the formulas now. So, I'm trying to think, maybe I should do it just within this function. Yeah, because I don't want there to be too much code. Okay, so it's going to be SABR of strike and forward rate price. So, okay, so yeah, we pretty much have every parameter. Let me go ahead and first I'll start off with these two functions. So I'm trying to think. Okay, yeah, I'll just make it in here. So the first one, auto zfin, I'll call it zfin equals. So it takes the. Oh right, I would need to pass more into. Okay, okay, I guess I will just keep this like this. I'll just call this grid because too much is going on in the function. So let me go ahead and copy this and then just come over here grid. So I'll call it grid equals grid. Okay, so now let me minimize this. So strikes and forward. Okay, now let me. Okay, first I'm gonna make these formulas like before I get too far ahead. So let me do double implied vol. It takes the argument of, so this will be double IV, initial volatility, not implied volatility, FT, K, strike, beta, um, so I'm going to compute Z, so F, so volatility, oh shit, okay, so, yeah, let me just avoid confusion, do double, V vol, double forward, double strike, double beta. Okay, so we have, yeah, this is so IV, VV, um, yeah, okay. So this will be so I'll do double Z equals V vol, volatility of volatility divided by IV times F of T times K, and this is to the power of, oh, not power, pow, of 1 minus beta divided by 2.0 times the log of FT divided by strike. Okay, so now double XZ is going to be the log of the power of 1 minus, oh wait, we also need rho, so double rho, 1 minus 2 times 2.0 times rho times Z plus the power of Z squared. 0.5. Okay, yeah, that'll take the square root plus Z minus rho. Oh, wait. Let me add an extra parenthesis here. So this will be divided by 1 minus rho. Okay. And now this final one. Okay, this one's a little intimidating, but we can get through this. So it's going to be, so we already, okay, so we need this component and this, okay, I'm just going to do this. So double adjustment is going to equal the power of 1 minus beta squared divided by 24. Let me just add 0.0. So then this will be times the power of IV squared divided by FT times K, and this is also going to be power to the 1 minus beta. Okay, plus rho times beta times IV times V vol divided by 4.0 times the power of ft times k to the power of 1 minus beta divided by 2.0 plus the power of vvol squared times 2 minus 3 times the power of rho squared. Yeah, let me go ahead and wait. So vvol squared divided by 24.0. Okay, so that's the adjustment. Okay, so now it will be, okay, so we got adjustment here. So now it will be return, so that'll be IV divided by FT times K. Oh, wait, this is going to be the power of this, 1 minus beta divided by 2.0 times Z divided by XZ times 1 plus adjustment. Okay, phew. That was quite the function. Okay, so now that we have the implied volatility, it's time to put it through the test. So it'll be so I'll comment this out and then I'll do double vol surface, and it'll be so it'll take let me just copy it from here. So Command C. I'll just call this XY. Okay, so this grid covers forward and strike. The next one, so we need to also include IV, vvol, rho, beta. So no, this is not going to be a double. This is going to be a vector. Yeah, vol surface is going to be a double. So I'm just going to come here and type in VS. Okay, so now that I got this, so yeah, this big ass formula has been coded in, so we don't need to worry about it anymore. So I'm just gonna exit that. Let me go ahead and declare a vector double called TS, which is gonna be temporary. So then we have okay, so this is gonna be std vector double vol z vol equals vol surface of grid, and then IV, which is going to be the vol of IV, vol of SV. Let me just double check the volatility. So parameters, yeah, IV, IVol, SV, volatility of volatility. So let me minimize that. So then IV, SV, what's next? Rho and beta. Yeah, rho and beta. Okay, so now we come to vol surface, and then we do for int I equals 0. I is less than xy of, what did I call it? Strikes. Dot size plus plus I, so ts dot clear, and then for int j equals 0, j is less than xy forward dot size plus plus j. So this will be ts dot pushback implied vol of iv vvol rho xy forward of ij xy strikes of ij so we got implied vol, no, initial vol, volatility of volatility, rho, the forward prices, the strikes, and beta. Oh yeah, and then I'm gonna come down here and do vs dot pushback ts, and then return vs. Okay, so now let me go ahead and minimize this function. So we got everything. So now it's time to do the plot. So I have matplotlib cpp over here. I have python.h. So what I'm gonna do is come here and do PyObject ax equals plt chart. Let me just double check. I haven't used this in quite some time. Oh no, I went up too much. Where is it? Chart. Yep, chart. So this is just going to be 111. And then let's see. So PLT plot surface 3D. Let me just double check in here. Surface 3D. So the color. Yeah, I want it with the color map, so it's going to be surface 3D map. So it's going to take the argument of AX. So grid of strikes, grid of shit. I want this to be like with the time. Or no. Let's just go with this. Yeah, forward price will be y-axis. That incorporates the time with it. And then z-axis is just going to be z-vol. And then the color. Okay, I'll do it to jet. And then the last item is line width. I'll just do it to 0.8. And then it'll be PLT show. Okay, so I'm going to do /SABR.sh. Hopefully there aren't too many errors in it. Oh, only one error. What was it? Requires 2 arguments, but 1. So this is this is the only error. Oh, I see. Okay, so what line is this? 137. 137. Okay. Oh shit. Let's see. Okay, so this parenthesis closes that. This with that. no matching function called to power. I don't quite know why. Requires two arguments, but one was provided. Hold on. Oh. Okay, this is where it went wrong. Yeah, so let me come to this formula. So 1 minus beta. Let me just boot up that, where was it? 1 minus beta squared. Okay, yeah, it's at the beginning of it. So that's why this errored out. So, okay. So 1 minus beta divided by 24 times okay plus this divided by this. Okay. Yeah, I think that fixed it. Let me go ahead and okay, dot slash SABR dot sh. Shouldn't have an error in it. Oh good, no error. So reset a dot out. Okay, so this is weird. I thought it would be like a curve. Okay, so this gives me time now to make it like bigger. It's like it's supposed to be an implied volatility. It looks like it. Okay, so yeah, this will give me time to yeah, I don't quite know what happened. Yeah, I think here. Let me go ahead and increase the time increments. So well, it makes sense because it's like the time. Okay, how about this? Let me go ahead and make the beta equal to 0.5. Let's see how this fares out with that. In the meantime, let me look and see where they have like x-axis, y-axis. All right, I'll just run it. A dot out. Okay, now I'm starting to see the curve. Okay, so yeah, 0.5. Okay, yeah, let's okay, so okay, I keep saying okay, 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 okay. Let me come over here to grid. I will do std vector double of teeth. So then it'll be std vector double temp z, and then it'll be temp z dot push back t of j, and then over here it'll be result expiry dot push back temp z. Okay, so this way we could avoid some confusion. So it'll be instead of forward expiry, yeah, expiry. And what I'm gonna do is I'm gonna make this animated before I go. I'm gonna Okay, I'll keep beta like that. What I'll do is I will come here and do, so how do I clear these? I programmed like half this library and I completely forgot how to use it, so yeah, bear with me. So scatter 2D, plot, where'd it go? I had, so get array, chart 3D axes names. Oh, okay. So I'll come here and do, so for double beta. Oh wait, I have to do okay, this is what I'll do. I will do Command X here. Um so I'm not doing any computations until I get here. So I'll do pi object there, and then I will tab these. Do I have beta inputted into here? No, I don't. So it'll be beta equals, or rather, I'll just get rid of beta, and then I'll come here and do for double beta equals 0.0, beta is less than or equal to 1.0, beta plus equals 0.01. So let me go ahead and cut this out, and then I don't want to search. So I'll add plt.pause 0.001. So then, what did I have here? Oh yeah, chart 3D axes name. So it'll be plt chart 3D's axes name AX. The x-axis is strike price. The y-axis is expiry, and the z-axis is implied volatility. Is that what the arguments were? Yeah. X, Y, Z. Okay, and then clear 3D chart. So that'll be PLT clear 3D chart AX. Is that the only input in there? Yep, that's the only input. So now I will come here, compile it again. One error, no matching function grid. Okay, that's weird. Oh, right. Okay, so that compiled. Now for good luck, let me bring back my camera. File, new movie recording. I know I gained some gray hairs doing this C++ video, but it had to be done. It had to be done. So I will come here, /a.out. Okay, so as the beta increases, wow, this is so cool. It gets more linear. And there we have it. So this is the implied volatility approximated by the Stochastic Alpha Beta Rho model. And I hope y'all enjoyed watching this video. It's 2025. I'm just going to keep coming out with more and more crazy videos, so stay tuned and peace out.